In the year 2040, it is estimated that 2/3 of the buildings standing now will still be standing then, and may still be standing in 2070. Unfortunately, these buildings are responsible for emitting the most carbon and using the most energy compared to any other sector. In order to reduce the climate crisis, the buildings of the past will need to be retrofitted to make a significant change within the built environment. Since the climate crisis is only growing over time, a global building standard will be enforced on all existing and new structures by 2070. As a result, people who own structures built without sustainable efforts in mind will be required to improve the building's climate impact. Rather than tear down these existing buildings that may include historical landmarks, we must find a way to save these buildings while still protecting the climate for the future. In order to solve this problem, an innovative technological device must be designed to analyze these existing buildings' envelope to determine what ways the building can be easily retrofitted, thus leading to a more environmentally responsible structure and future. Owners of these non-conforming structures will be required to contact climate control specialists who will bring this device on site to analyze the structure three-dimensionally. This device will measure sunlight, temperatures, and even age to create a strategic plan to best restore the building to mitigate climate problems. This analysis will take several days and will require the tenants of the space to temporarily vacate in order to best analyze the building's components. This in-depth analysis will require the device to be moved several times throughout the building to guarantee the building's climate impact is diagnosed thoroughly. As the system moves through the building, it will analyze the weak points of the envelope, such as poor insulated features, hot spots, material quality, and even carbon emissions. After the analysis is complete, it will then generate a diagnostic list of components that the owner should replace or reinvent to create a stronger, more sustainable living building. This may include re-insulating the structure, replacing old materials, eliminating windows, or integrating new sustainable systems into the structure to decrease energy consumption and carbon emissions. Since buildings are part of living landscapes that change daily, seasonally, and even yearly, this analysis must take all of these factors into consideration for the best diagnostic results. Ultimately, this will lead to living buildings that may change daily or seasonally in order to adapt in their changing conditions and create climate-responsible structures. This may mean encouraging the owner to integrate glazing that controls how much light enters the building based on the sun's location throughout the year, or even designing flexible spaces that integrate movable thermal walls at times to allow for maximum passive heating, which are removed as temperatures increase during the summer. As a result, the spaces of the future will be based on seasonality and recognize the importance of structures living in their environment rather than over it. This shift in technology can lead to more people becoming aware of how buildings must live and adapt in their unique environment. Houses located in Flagstaff will respond to the climate there far differently than houses in Phoenix, since the environments they are based in are vastly different. Ultimately, people will gain greater respect for the way they understand structures, space, and even components as they begin to understand the direct impact the buildings of the past will have over the climate of tomorrow.